Hello everybody, this is Mr. Yen, and in this video I'm going to be guiding you through lesson 8.1, how to calculate the slope and the distance between 2 points. So you'll want to have this slide pulled up, and we're going to start with slide number 1. In this slide you'll see on the right that we have a graph, and there are 2 points on the graph, these 2 points in green. The first thing that we can do is list the x and y coordinates of those 2 points. So let's look at the point on the left right here. So the x value of this point, checking the x-axis, is -3, and the y value of the point is +8, so I'll fill that in here. X of -3, y of +8. The next point on the right has an x of +5 and a y of -2. X of +5, y of -2. Okay, and then the next part asks us, what is the slope between those 2 points? And for this activity, between each 2 points, you're going to make a slope triangle. What a slope triangle is a right triangle that connects the 2 points where the hypotenuse goes between the 2 points. So remember, the hypotenuse is the long side of the right triangle, this side right here. So to do that, I'll go ahead and I'll line up the top of the triangle here with this top point. And I'm going to have to bring the triangle over to the right. So I'm going to click and drag and bring it up to here, and then drag this base down so that it lines up with the second point. And so now you can see my slope triangle, the hypotenuse of the slope triangle is going between the 2 points. This slope triangle helps us see what the slope is, and it helps us calculate what the distance is between those 2 points. So remember, slope is the difference between the two y values, y2 minus y1. So y2 is this y value right here, -2, and y1 is this y value of this point, which is 8. So I'll say the slope, y2 minus y1, that's -2 minus 8. Then the denominator of the slope is x2 minus x1. x2 is this x value right here, 5, minus this x value right here, -3. So I'll say 5 minus -3. Then I can keep calculating. -2 minus 8, that's -10. 5 minus -3, that's 8. I can simplify this further. Both of these numbers can be divided by 2. So divide the numerator by 2, -10 divided by 2, and I will get -5. Denominator, 8 divided by -2, and I will get 4. That's the furthest that I can simplify this fraction. So my slope between these 2 points is -5/4. I know the slope is negative because looking from left to right, we're going on a downhill. Okay. Now, if we look at the slope triangle, this vertical leg of the slope triangle is also my difference between these two y values. So this leg is going from a y of +8 down to a y of -2. The difference between those two numbers, 8 minus -2, is 10. Right? I can get this difference by subtracting, or you can also, if you have the full grid, you can count the squares, right? Between here and here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. Then this horizontal leg of the slope triangle is the difference between this x value at this corner to this x value of this point. So we're going from an x of -3 to an x of 5. The difference between 5 and -3, 5 minus -3, is 8. So I can get that length by doing subtraction like I just did, or you can count the squares. 1, 2, 3, 4, 5, 6, 7, 8. That's how it's a length of 8. Notice that these two lengths, 10 and 8, are the same numbers that I'm using in my slope, right here, -10 and 8. The only difference is, since distance is always positive, it's the absolute value of -10, which is +10. Okay. And this slope triangle is helpful for us because we can use the Pythagorean theorem to calculate this length between these 2 points, because the length between these 2 points is like the hypotenuse of this slope triangle, which is a right triangle. And so the Pythagorean theorem, you know it either as leg 1 squared plus leg 2 squared is equal to the hypotenuse squared, or you might know it as a squared plus b squared is equal to c squared, where c is always the hypotenuse, the long side. So we can start to fill out our Pythagorean theorem. What I'm going to do is I'm just going to copy this whole equation. So you press Control C or Command C, and then paste it right below by pressing Control V or Command V. And then I can start filling out the information. So leg 1, that can be either of the legs. I'm going to use this leg here, which is 10. Leg 2, which is this leg right here, is 8. So it's going to be 8. And then hypotenuse, that's what we're trying to figure out. So I'll leave that as a variable. And then I can continue working. I'm just going to copy paste again. 10 squared, that's 10 times itself. So 10 times 10 is 100. 8 squared, that's 8 times itself. So 8 times 8 is 64. So I'll say 64 here, and that's equal to the hypotenuse squared. That's what we're trying to solve for. I can continue simplifying. And copy paste again. 100 plus 64, that's 164 is equal to h squared. Now we don't want h squared, we want to figure out what h is. Remember, to undo something that's squared, you have to square root something. And so for that, I've provided you with this symbol down here. This is the square root symbol. So what we're going to do is we're going to take the square root of both sides. So we need square root of 164 is equal to h, because the square root of h squared, it undoes the squaring, and it's equal to h. So now we know that this length, this hypotenuse, which is the distance between those 2 points, is the square root of 164. I'm just going to rearrange this real quick. H is equal to the square root of 164. Square root of 164 is not a perfect square, so we can leave it in exact form like this, or we can estimate, or we can round. So what I'm going to do now is switch over to a calculator. I just Google searched calculator. I'm going to click square root of 164 is equal to this number here. I'm going to round it to the nearest hundreds place. That's this second number after the decimal. So this would round up to a 1. So rounded would be 12.81 or 12 and 81 hundredths. So square root of 164 is equal to 12.81 units. That is my final answer, as the distance between those 2 points using the slope triangle. Now, an important thing to remember, notice how when we are using the lengths of these legs, right, we're using the numbers from the unsimplified slope, right? That was the -10 and the 8. A lot of times what students will do is they will use the numbers from their simplified slope as the lengths of the 2 legs. But notice if you do that, right? If I use the lengths 5 and 4 instead of 10 and 8, what I'm actually doing is I am shortening the length, or shortening the distance, right? This is 5, 4. And notice how this triangle doesn't go fully in between those 2 points. So make sure that you use the lengths from your make sure you use the lengths from your unsimplified slope. Let's bring this back all the way down to, sorry about that. Okay, so the key thing to remember here is when calculating distance, use the numbers from the unsimplified slope. Okay, so you're going to do something similar for problems 2, 3, and 4.